Hello, we are back here with Learning with Mr. Neff. Alright, I am here to be real with you today. Because we're classifying real numbers. And so I'm going to help you have a better understanding of something that can be pretty confusing and make a video that's been long time overdue. I want you to picture all the numbers of the world if they were packed into a box, that we call them real numbers. Now you say that's kind of weird because there's, not fake numbers, but actually there are imaginary numbers, which if you're really curious, square root of -1, we'll start there. But you're not going to learn that right now. So I want you to picture this box of real numbers, and inside what I'm going to teach you to unpack is we're going to unpack this into smaller boxes, as I'll talk about rational and irrational, and then they'll break down to integers, whole, and natural. So this will all come up here. You don't need to jot this down right now. But that's this idea of subsets of the real numbers, okay? So now, to help you understand this, I'm going to show it this way for you. Real numbers, that's all the numbers in the world. That's the giant box. We're taking a look in there. From there, then they break down into two boxes. All of them are either rational or irrational. Rational can be written as the fraction, we'll say a over b. That means you can write these numbers as fractions. Ratio, think of rational. And so the word ratio is right there. 0.5, 0.33 repeating, 4/5, all can be written as fractions. And you might say, well, how is that? Well, if 0.5 can be written as 1/2, or 0.33 repeating could be written as 1/3. Or 4/5 would be, well, 4/5, right? It's already written that way. I see my scribbles. And there's other things that we'll talk about, like 1 1/3. Well, that would be, that's 1 1/3. That would be written as 4/3. And so that would be an example of a rational number. Now, if you cannot do this, if you cannot come up with these two numbers, then that would be called irrational. The most famous irrational number is pi. We know it's the ratio of circumference of diameter, but we cannot come up with two, we say integers, a over b, two whole numbers that would equal that number. Square root of 2, the square root of 3, the square root of 5, right? So now notice I jumped over the square root of 4, as I'll allude to later, because square root of 4 equals 2. So that's going to fall into the left side here, the green side of the rational. All right, irrational, a lot of times when I explain that there's no two numbers that would equal this square root of 2, they'll go, that doesn't make any sense. And I'll go, well, yeah, what's the definition of irrational? It doesn't make any sense. And so it won't make any sense. Rational makes plenty of sense. That's the idea of what the word rational means. Okay, so now let's talk about the rational side. We've got smaller boxes here. Irrational, we can't find patterns when there is no pattern. But with rational, we have patterns here. So we'll move on. And the next box is integers. Those are your non-decimal numbers as you see here. -3, -2, -1, 0, 1, 2, 3, ... means on to infinity both ways. But notice what that means is there's commas. So that means -2.5 and -1.5 and anything in between there is not an integer. So it'd be -3.0 if you think of it that way, -2.0, -1.0, all the way through up to 1.0, 2.0, 3.0. That is your integers. Okay. The next one, just swipe off all the negatives here. All right, if you could picture that, we would swipe off all the negatives, and we would have whole numbers. They're positive integers and 0. So we start 0, 1, 2, 3, 4, all the way on. Okay, that's that. And then the last one, which would be natural numbers. It would be natural numbers, counting numbers, 1, 2, 3, ... and so forth. And that would be showing you all of the ones there. Now really, how you learn math is from the inside out. When you first learned, you learned about 1, 2, 3. And then probably you learned, you had 1 cookie, 2 cookies, 3 cookies, and then you had 0 because somebody stole all the cookies or ate all the cookies. So you learned about 0. Then you learned that there was things like take away, or you owed or something, and you got negatives. Then after that, you learned about fractions that you would have. And then now you're learning about irrational numbers. So it's kind of how you work backwards to get there. But those are the boxes. All right, right there. You see the boxes broke down of what are the subsets of the real numbers. Okay? So now let me go forward here and give you a couple of reminders here. So again, rational numbers can be written in the fraction form a over b. So there are two integers. They have to be integers. All right, so what I mean is -4. All right, could be written as -4 over 1. So that's why it's rational. 4 can be written as 4/10. All right. Or 1.4 can be written as 1 4/10 or 14 over 10. So what's A? Here, -4. What's B? 1. What's A? 4. What's B? 10. What's A? 14. What's B? 10. Now, rational numbers, we cannot do that. So when we say the pi, we go, what makes up pi? Well, it's about 3.14, but it's not exactly that. Or what makes up square root of 2? Well, it's about 1.4, but it's not exactly that. And it doesn't make any sense. So irrational doesn't make any sense. Okay, so yes fraction, no fraction. That's the easiest way to think about that. All right. The other thing I want to point out, perfect square roots are rational, integers, whole, and natural. They're in all those. What's square root of 1 is 1. All right, square root of 4 is 2. Square root of 9 is 3. Square root of 16 is 4. So when I'm talking about these right here, right, when I square root those, okay, when I square root those, I get those numbers going back up to this particular slide, right? So that would fall in the natural. The square root of 2 would fall right down in here. Oh, nope, I said that wrong. Square root of 4 would fall right down in there, which would equal 2, right? And let's not even bother writing that, okay? All right, let's move on. So we were here, right? Now, one more thing. Here's just a thing to help you remember this, because it's hard for students to remember. There is 0 difference between whole and natural numbers. What do I mean? Well, the whole numbers, as you saw earlier, were 0, 1, 2, 3, 4. And the natural numbers are 0, 1, 2, 3. So the whole has a 0. There is 0 difference between whole and natural numbers. Just a little thing to help you remember that. Okay, now you try. So go ahead, if you want to pause this, that's fine. Just take a moment. I have all these listed out here, and then I'm going to just show you the answers to what they are here in just a moment here. Okay, so 4, what is it? 3/5. What is it? What all are they? So what I mean is, what I say is, which boxes would they be in? Okay, so like they could be in all of these. So if it's 3, then you would list out all 4 of these. So go ahead, and I really encourage you, if you're listening to this, trying to learn this material, pause it, take a guess, and see what you come up with. Okay, so and now let me show you the answers here. Okay, 4, obviously that's a counting number. It's in all of those on the left side. Never will you ever say irrational and rational at the same time. Irrational always is in its own category. This, of course, is in a fraction, rational. This is also, it'd be 2 1/4, which would translate to A being 9 and B being 4. Of course, this one, by the way, is 4 over 1. Okay, 1 2/3 would translate to 5 over 3. Those would be A and B. Again, this square root of 25 is 5. My square root of 26 doesn't come out pretty, and that's irrational. Now 3.14, notice I said earlier pi was irrational. I actually missed this one in college when I wasn't thinking, you know. The 3.14 is not pi. It's just an approximation of pi, which is 3 and 14/100ths. So that would be able to be written as A would be 314 and B would be 100, and it would be rational. Okay, let me give you one more try at this then, all right? So you can go ahead and pause. I got 6 more here for you just to take a guess where they fall, and I'll just go ahead and click that here in a second and show you what it is, okay? So these are ones that people commonly miss, and ready, go. All right, square root of 10, yep, that doesn't come out pretty for us. Now here's an interesting one, square root of 1.44. Really, that, when you square root it, is 1.2. And what's interesting about that is the square root of 144 is 12. And so the square root of 1.44 is 1.2. So that's written as 1 1/5, or that would actually be the fraction 6 over 5. So A would be 6 and B would be 5, and it is rational. Okay, irrational here. This is not a repeating decimal. So again, I didn't say this really clearly. Repeating decimals and terminating decimals are rational. This one here is not. It's not repeating. It has a pattern that goes on forever. Generally, we say it goes on forever without a pattern, but this has a pattern. It just isn't a repeating pattern, a repeating decimal, and therefore it is irrational. Pi, like I said, is irrational. 22 over 7, the reason why I picked that is if you take 22 divided by 7, you get a really weird decimal. It's actually a repeating decimal, but people will put in their calculator, see that really weird decimal, and it's really weird because it repeats 6 digits at the same time, and that's pretty crazy. That's why people get confused in their calculator with that one. So that's why I put that one on there. And then, of course, 0, we talked about this one, rational, integer, and whole, but not natural. So that is all we have time for with Learning with Mr. Neff. Thanks. I hope you enjoyed it. Have a great day.